welcome in your own chemistry class. We are starting here a new chapter 4, that is electrochemistry. This is the first video of this chapter, and in this video we will discuss about the introduction of the chemical kinetics and what are the rates of reaction and how many types of rate of reaction or how many expressions we can show to the rate of reactions. Okay, first of all, introduction means what is chemical kinetics. Actually, chemical kinetics is the branch of chemistry in which we study about the rate of reactions and factors affecting the rate of reactions. Okay, means the chemical kinetics is the branch of chemistry in which rate of reaction and factors affecting the rate of reactions are studied. Okay, so first of all we discuss about the reactions are divided into three types on the basis of rate. Okay, on the basis of rate, the reactions are divided into three parts. Reactions are of three types on the basis of rate means instantaneous or ionic reactions means very fast. Very slow or molecular reaction taking place in such a low speed that we can say the reaction is complete in days or years. Okay, and slow reactions, so slow reactions means it takes place at normal speed. Okay, so we will differentiate all the three types of reactions. Instantaneous reactions, we can say ionic reaction. All the ionic reactions takes place at very high speed. Very slow reaction or molecular reaction or reactions of covalent compounds are very slow process. Slow reactions means the speed of slow reaction is faster than very slow reaction but slower than instantaneous reactions. Okay, so see, instantaneous reaction takes place with very high speed. They are completed with the twinkling of an eye. Just twinkling an eye. These reactions takes place with such a low speed that there is no visible or measurable change even for days or months. And slow reactions takes place with normal speed. They tend towards completion in minutes or in hours. Okay, examples of these reactions. See, example here, ionic reactions. All ionic reactions such as acidic reaction between acid and base, HCl plus NaOH is equal to NH plus H2O, or NaCl plus AgNO3 is equal to NaNO3 plus AgCl. Within seconds, the reaction is completed. Here, very slow reaction, formation of biofuels, okay, or fossil fuel, formation of fossil fuel, decay of rocks, conversion of carbon into diamond. Okay, these all the reactions are very slow and completed in years, many of years. And slow reactions just like decomposition of N2O5 on heating decomposed into 4NO2 plus O2, or we can say reaction between acetic acid and ethyl alcohol. Acetic acid means CS3COH, ethyl alcohol means C2H5OH. When these are mixed, then CS3COOC2H5 means ester is formed with water. This is also a slow reaction, not very slow and not very fast. It is slower reaction. It is actually organic reaction. Okay, thus there are three types of reaction on the basis of rate. Okay, now we will discuss about the what is rate actually. Reaction, what is this? The change in concentration of reactants or products per unit time is known as the rate of reaction. Okay, what is it is means, see, reactants means R is converting into product P. Okay, suppose there is 0.1 m concentration of reactant and it is converting into product after 10 minutes. Suppose its reaction is decreased 0.02 m. Okay, this is decreased and product is formed. So the rate of reaction of this reaction will be the change in concentration of reactant. There is no reaction concentration is given of product. The reaction change in reactant means 0.1 minus 0.2 0 to, this is the change in 10 minutes means upon 10 minutes. This will be the rate of reaction. The rate of reaction is represented by the change in concentration of reactant or the change in concentration of product. And as we know that as reaction takes place, the concentration of reactant decreases continuously while the concentration of product increases continuously. So we can say the rate of reaction is change in the or we can say the decrease in the concentration of reactant per unit time or the increase in the concentration of the product per unit time. So see, R is equal to plus minus means increase or decrease, change in concentration per unit time dc upon dt. Can we say decrease in concentration of reactant upon time period means minus dc upon dt, or we can say that increase in the concentration of product upon time period means plus dc upon dt. It is according to product and it is according to reactant. We can show this by graph. See, when we plot a graph between concentration and time for reactant, the graph is this type. Means as time increases, the concentration of reactant decreases. Why? Because the reactant is converted into product. And when we plot the graph between concentration of and time for product, then the concentration as according to time increases as reactions takes place. Okay, and by combining these two graphs we get this graph. It is the concentration of reactant and it is the concentration of product. Okay, clear? This is the rate of reaction by this graph. This is concentration, this is T. We can calculate the change in concentration per unit time. Okay, now rate of chemical reaction is expressed in three types: average rate, instantaneous rate and initial rate. Okay, three types. Generally we use average rate and instantaneous rate. What is average rate? Average means generally average we say that at T1 time the concentration was C1 of the product, and at T2 time the concentration is increased by C2. So what will be the rate of the average rate of the reaction? So there is change in concentration is C2 minus C1 and time period is T2 minus T1. So the average rate will be the C2 minus C1 upon T2 minus T1. Okay, actually the rate of reaction, general rate of reaction, this is actually the average rate of reaction. So it is determined by dividing the change in concentration by time taken for the change. R average, EVG means average rate is equal to plus minus delta C upon delta T. Plus minus means plus for the change in concentration of product and minus for the change in concentration of reactant. Okay, see some examples about this. See, this is the graph between the concentration of reactant and the time. It is the decrease in the concentration of the reactant as time is passed. Okay, so see, it is the T1 time and the concentration was R1, and after delta T time means T2, the concentration decreased to R2. So the R average will equal delta R upon delta T. Delta R means R1 minus R2 and delta T means T2 minus T1. Okay, it is the average rate R AB or RV ABG. Okay, clear? See the example. For the reaction R is equal to P, the concentration of reactant changed from 0.03 m to 0.201 m in 25 minutes. Calculate the average rate of reaction in minutes and seconds also. RABG means minus dr upon dt. R is okay. So dr means change in the concentration of R. This is changed into 0.03 to 0.02 means 0.03 minus 0.02 upon time is given 25 minutes 25. So it will be 0.01 upon 25 means 4 into 10 to the power minus 4 mole per liter per minute. This is the unit of rate of reaction, moles per liter. It is the concentration. Okay, the concentration means mole per liter upon time. Here time is given in minutes, so the unit will be mole per liter per minute. It is in minutes, and we have to calculate the unit in seconds also. So we, to calculate the answer in seconds, we have to divide it by the seconds, means 4 into 10 to the power minus 0.60. Then the answer will be 6.67 into 10 to the power minus moles per liter per second. Okay, clear? Thus we can calculate the average rate of reaction. Clear? Second one is initial rate of reaction. Initial means in starting. The rate of reaction at t is equal to 0. At t is equal to 0 means that the reaction is just to be started, is called the initial rate of reaction. It can be determined by the graph. See, this is the general graph of reactant between the concentration and time. Okay, we extrapolated this graph to the concentration axis, or we can say y axis, and then we draw a tangent on this curve or on this graph. Then the slope of this tangent is determined, show the initial rate of reaction. Means R initial is equal to minus dc upon minus t. When limit t is equals to 0. Okay, graph is extrapolated to y-axis and a tangent is drawn. The slope of tangent gives initial R initial. It is the tangent, and this its slope will give the R initial. Okay, clear? Next, instant rate. What is instant rate? Instant means at a time, at fixed time. The rate of reaction at particular time or instance is called the instantaneous rate of reaction. Just like in our vehicles, the speedometer gives us the instant speed of the vehicle. We are going at 60 kilometers per hour or 80 kilometers per hour. That is the instantaneous speed. And average speed, see, understand the difference between average and instantaneous. Such as we are saying that we are going at 80 km per hour. This is the instant speed, and we say that at 12 am we start our journey and completes 200 kilometers at about 2 p.m. Okay, means 4 hours are taken to travel this journey. So the average rate will be 200 kilometers upon 4 hours, means 50 kilometer per hour. Okay, this is the average speed and this is the instantaneous speed. This is the difference between instantaneous rate of reaction, means the rate of reaction at a particular time, and average means the change in concentration in total and the time taken to change in the total concentration. Okay, so the rate of reaction at particular time in our instance is called the instantaneous rate of reaction. R instance is equal to plus minus dc upon dt, when dt is the very small time and dc is the change in concentration at in dt time. It is also determined by the graph. How? See, this is the general graph between concentration and time for the reactants. There is a change in the concentration at we are plotting a tangent. We are drawn a tangent on this plot, and is this tangent, the slope of this tangent, this is slope, means dc upon dt, shows the r instance. A tangent is drawn at the particular instance. The slope of tangent give r instance. Okay, clear? This is the instant rate of reaction. Next thing we'll be discussing in this video, it is the relation between reaction rate and the stoichiometric coefficients. It is very simple. See, for any chemical reaction, A plus B is equal to C plus D. A and B are the reactants and C and D are the products, and N, M are the number of moles of reactants, or in P and Q are the number of moles of the products, or we can say these are the stoichiometric coefficients of the reactants and products. So according to stoichiometry, the rate of reaction R will be given by in this way, means rate of reaction is equal to plus minus dc upon dt. Okay, for when the stoichiometric coefficients are given, then in rate of reaction the stoichiometric coefficient also take parts. The rate of reaction is divided by the stoichiometric coefficient also. Means plus dc upon dt, this is the complete rate of reaction, will be equal to 1 upon n divided dA upon dt is equal to 1 upon m, minus means decrease, 1 upon m dB upon dt. dc upon dt will be divided by p, and dd upon dt will be divided by q, where n and m are the stoichiometric coefficient of the A and B, and p and q are the stoichiometric coefficient of C and D. See by the example, just one, n2 plus 3h2 is equal to ns3. Then R will be equal to minus dn2 upon dt, there is no any stoichiometric coefficient, is equal to 1 upon 3, there is 3, so it is 1 upon 3 dh2 upon dt is equal to plus 1 upon 2, this is the stoichiometric coefficient to 1 upon 2 dns3 upon dt. Same example, 5br minus plus brO3 minus plus 6h plus is equal to 3br2 plus 3h2. 5, 6, 3 and 3 are the stoichiometric coefficients, so their dx upon dt is divided by these stoichiometric coefficient, means R is equal to minus 1 upon f, minus is used for the reactants and plus is used for the products. Minus 1 upon 5 dbr minus upon dt is equal to minus dBrO3 minus upon dt, there is no any stoichiometric coefficient, there is 6, so minus 1 upon 6 dH plus upon dt is equal to plus 1 upon 3 dBr2 upon dt is equal to 1 upon 3 dH2 upon dt. Thus we can calculate also the relation between the disappearance of the rate of disappearance of the reactants and the rate of formation of the products also. For example, in the following reaction, Cl2 plus 2I minus is equal to I2 plus Cl minus, the initial concentration of I minus this is 0.30 moles per liter. The concentration of I minus becomes 0.25 moles per liter after 10 minutes. Then determine the rate of disappearance of I minus and the rate of formation of I2. First of all, we have to write the stoichiometric relationship between the rate of reactions. Means R will be equal to minus dCl2 upon dt, according to this, is equal to minus 1 upon 2, there is 2, so 1 upon 2 di minus upon dt is equal to di2 upon dt, there is no any stoichiometric coefficient, is equal to plus 1 upon 2, there is 2, so 1 upon 2 dCl minus dt. Okay, we have to calculate the di minus upon dt and di2 minus upon dt. First of all, 1 upon 2 di minus dt is equal to di2 upon dt. Relation between the rate of disappearance of I minus and rate of formation of I2. This is the relation from the stoichiometric equation. So according to question, the change in concentration of I minus is given in 10 minutes. So the rate of disappearance of I minus will be equal to di minus upon dt is equal to 0.30 minus 0.25 upon 10. So it will be 0.05 upon 10, means 5 into 10 to the power minus 3 moles per liters per second. Okay, per minute, it is per minute. Moles of formation of I2 means di2 upon I minus dt is equal to 1 upon 2 di minus upon dt. This is the relation. Okay, so the value of di upon dt, di minus upon dt is 5 into 10 to the power minus 3. So we will put the value of this, then the answer will be 2.5 into 10 to the power minus 3 moles per liter per minute. This is per minute, not second. Okay, see one more example for a reaction. X plus y is equal to 2z. The rate of disappearance of x is found to be 10 to the power minus 3. Means dx upon dt is equal to 10 to the minus 3 moles per liter per second. So find the rate at which y disappears and rate at which z is formed. So first of all, according to stoichiometry, R is equal to dx upon dt is equal to dy upon dt is equal to 1 upon 2 dz upon dt. This is the relationship. Okay, given dx upon dt is given, this is 10 to the power minus 3. Okay, so according to stoichiometry, dx upon dt is equal to dy upon dt. So dy is just same according to dx upon dt. This is 10 to the power minus 3 moles per liter per second. Now we have to calculate the dz upon dt. According to stoichiometry, dz upon dt is equal to dx upon dt into 2, because there is 2 is here multiplied. So 2 into 10 to the power minus 3 moles per liter per second. It is the rate at which Z is formed and it is the rate at which Y is disappeared. Okay, clear? Any problem? Very good. See one more example. In the reaction 2A is equal to B plus 4C, the concentration of C is increased by 2 into 10 to the power minus 2 moles per liter per minute in 10 seconds, sorry, not per minute, 2 into 10 to the power 2 moles per liter in 10 seconds. Calculate the rate of formation of C and the rate at which A disappears. First of all, we have to show the stoichiometry. R means rate of reaction will be equal to 1 upon 2 d upon dt is equal to dB upon dt is equal to 1 upon 4 dC upon dt. So first of all, we have to calculate the change in, according to change in concentration, the rate of formation of C means dC upon dt will be equal to 2 into 10 to the power minus 2 upon 10 means 2 into 10 to the power minus 3 moles per liter per second. It is the rate of formation of C. Clear? Now we have to calculate the rate of disappearance of A. So we have to write the relation between dA upon dt and dC upon dt. It is half, 1 upon 2 d upon dt is equal to 1 upon 4 dC upon dt. It is, or we can say d upon dt is equal to 2 upon 4 into dC upon dt. 2 upon 4 means 1 upon 2 and dC upon dt is calculated 2 into 10 to the power minus 3. So the answer will be 10 to the power minus 3 moles per liter second inverse. Okay, this is the rate at which C is formed and this is the rate at which A is disappeared. Clear? Next example. In a reaction 2A is equal to product, the concentration of A decreases from 0.5 moles per liter to 0.4 moles per liter in 10 minutes. Then calculate the rate during this interval. Means R average is equal to minus half 1 upon 2. There is stoichiometric coefficient is 2 d upon dt upon d, 1 upon 2 dA means the change in concentration is 0.5 to 0.4 means 0.5 minus 0.1 upon the time interval is 10 minutes. 10. Then 1 upon 2 is into 0.1 upon 10. Then we calculate, the answer will be 5 into 10 to the power minus 3 moles per liter per minute. In this way, we can calculate the average rate of reaction or the rate of the disappearance and the rate of the formation of the products. Okay, just we know the stoichiometric relations between the rate of reaction and the change in concentration of reactants and products also. Thank you.